thank you for joining me for a coffee with the editor. It's been a long time since I was last in this facility. So I think let's just do an introduction because it's been a while. So Brenton, let's start with you.
Brenton, the Managing Director. I joined Booyco in 2014. In 2019, Grant and myself bought out the previous shareholders. So basically been in charge of operations strategy since then, ably assisted by our technical guru.
I joined Booyco in 2006, so I've been here for 16 years. Started out as an engineering manager, then program manager, and then obviously now executive director and responsible for engineering, quality and sales within the company.
I think it's a good idea just to take my audience through how you've been servicing the rail sector.
Started off in military, and then from there evolved into rail in the last decade or so, focusing more on the export market and dealing with OEMs, so dealing with the likes of Bombardier, Alstom, Siemens, GE, various others. So, really, I think we've migrated from being a rather smallish jobbing type of business to being involved with larger rail contracts with over multiple years, delivery schedules, multiple hundreds of units. So, it's been a bit of a journey to get to where we are now. Okay,
so technical guru, I'm assuming that's you.
Hopefully, yes.
Explain to me the actual product range that you offer, because it's for freights, locomotives and passenger.
Predominantly it's HVAC systems for railway. Okay. Recently, for Bombardier, we assisted them in designing a cooling tower for electric locomotives as well. Okay. We became the first South African supplier to locally manufacture a cooling tower, which to us was quite a nice feather in our cap for that.
And we only one of 3 approved cooling tower suppliers for Bombardier in the world.
And a cooling tower is far more critical to locomotive operation than an HVAC. Okay, if the cooling tower fails, the loco doesn't move. So it's quite an important part of the locomotive, and we are now the official supplier for Bombardier in South Africa for this product.
So let me just check in with you as the official supplier for Bombardier on those products. Does that automatically transfer to Alstom?
Yes.
So because there is really no Bombardier.
Effectively, when Alstom bought out Bombardier, we now supply Alstom those exact same cooling towers, and HVAC system for that locomotive.
And how does that impact, like, for example, the Gibela project? Are you supplying to that?
So we are supplying components for Gibela. It's in the, driver comfort range, but not HVACs yet. We are still talking to them about that contract. So we do supply. So Gibela is obviously controlled by Alstom, but we do deal with Gibela directly in South Africa, not really with Alstom for the Gibela side of the work.
So the cooling towers would be for...
Cooling towers is very specific to locomotives.
Okay.
So passenger trains, they do have a very small cooling tower because there's not as much tractive effort. The cooling tower, essentially how it works is, you'd have overhead catenary voltage that needs to be converted or transformed into whatever voltage is used in the traction motors, and generally there's a lot of heat that needs to be dissipated from some regions 300-400 kilowatts. So the cooling tower would then, because obviously locomotives are megawatts and they need to pull very long freight trains that are generally quite heavy. Okay, so the cooling tower then needs to dissipate that heat, similar to the way a radiator works in a car. Your engine generates heat and then it needs to dissipate that heat, and that's what a cooling tower does for an electric locomotive. Okay, so passenger trains, while still heavy, are don't require nearly as much tractive effort as a loco. So they do have cooling towers, but they're significantly smaller, and we've spoken to them about that, but they had an existing system that they prefer to use for cost reasons.
Anything from a loco, whether it's the loco or the saloon, we have supplied products when it comes to heating, cooling and extraction for both vehicle types. So whether it's a driver HVAC cab or the cooling tower or a heated footrest or footwell heaters or heaters in the saloons, we have supplied to Alstom, Bombardier, all of those various components. So on some projects we only supply one, on others we supply two. Bombardier, we supply the full suite on the locos. So really anything that heats or cools, we've supplied somewhere over the last decade.
Yeah.
In terms of like previous experience, the 19Es, the 15Es.
Yes. That system was the first one, was developed with then Union Carriage. That was our first experience with more international standards. So the specifications, the EN requirements. So previously we would get a specification. In South Africa, it sort of is, okay, we want an air conditioner for our train. Okay, so we'd go there, we'd measure things up, and we'd understand what exactly is the customer looking for, and we'd design them an air conditioner. Okay, the expectation was that it would cool down the cab. Okay, whereas the international guys, they would give you a rather thick specification and say, this is exactly what we want. Okay, everything is detailed, everything is specified. Okay, it's not only that it must cool down the cab. That's an expected. That's what an aircon does. It has to do that. But then it's all the other things. So it's got to meet sort of EMC, EMI requirements. It's got to pass vibration tests. It's got to various reliability requirements. It must operate for this long without failures, or based on a sample size. So that's where we really started to get into this and actually understand this, and as opposed to just building an aircon that just cooled down a cab. Okay, like I said, that's expected to happen. That's what an aircon does. But now, so we started there with 19E. Then Transnet liked that system so much that they asked us to incorporate it into all the other electric locomotives that they were building. So we then, obviously, everything's slightly different, but it's essentially the same system throughout the electric locomotive range. Okay. When it got to Bombardier, it really got into the detailed, heavy paperwork, because everything has to be verified. So you start with a calculation, you verify your calculation, then you'll go through a CFD or an FEA analysis in order to make sure that what you said on your calculations is actually translating through to that. And then you do a physical test. Okay, and the idea is that the test is almost a formality to verify all the calculations and all the simulations that you've done to verify.
Now we can run a simulation on the software, and we can sort out most of the issues before we build the prototype. So typically you build a prototype, you put it through a vibration test. If it breaks, you have to go and figure out what went wrong, build a new prototype. So we can cut down on that development significantly by running the simulations and then just doing the final vibration test to prove that what the computer said happens.
For the cooling tower for Bombardier, while components were vibration tested, the actual structure never went through a vibration test. We only did FEAs to verify the structure. Because of the size of the cooling tower, vibration tables, they struggle to physically test it, because the cooling tower itself weighs about 1.5 tons. So finding a vibration table that can manage that is a problem. Okay, so Bombardier was quite happy that we just do an FEA. It was a very, very detailed FEA, but it was just an FEA. So that system is effectively, the whole system hasn't undergone a vibration test. It has been operating on a loco for the last 5 years, which sort of proves that it does work, and we haven't any structural failures. So
obviously all this experience in terms of meeting international requirements and that kind of certification,
yes,
for want of a better word, has obviously impacted your product development here locally. So you are now developing quality products for the railway industry, both in South Africa and exporting into the African market.
So, we've got units running in Africa, South America, some in Europe, there's some in North America. So, we effectively, as far as General Electric is concerned, WABCO now, we basically their supplier of the driver HVACs for their Class 44, and that logo is deployed all over the world. So we actually, from an export point of view, the exact same amount of locos that we supplied in South Africa, we exported to GE in America. The experience that we've garnished over the last couple of years has definitely put us in a position where we are able to compete technically in the international market.
So there's new builds, and then of course these things need to be maintained.
Yes.
Spare parts. How do you manage this process? Do you manufacture here? How does it work?
So we manufacture everything here. We design the units from scratch. We then assemble the units. In South Africa, we have 12 technicians based around the country, so we basically look after probably 90% of the Transnet fleet. Internationally, we've got agreements with service providers where we train them and they then provide the support, but we supply all the spare parts. So when we design the units, part of that is a maintenance program, midlife upgrades, etc. All of that gets logged, obviously shared with the customer, and then we've got a unit history file on every single unit that we build. So any repair gets logged onto the unit history file, so we can tell you exactly on each unit what we've replaced when. If there is a trend, that goes back to our engineering department to see whether we need to improve the design, if it's possible. Locally we maintain, and internationally we've got quite a few service agreements, like I said, with approved service providers. Some of Africa we do ourselves, so we'll send technicians up. And I mean, if there's really a serious issue, which doesn't happen that often, we'll send one of our field technicians across, or our production manager. He's been with us, I think, longer than what Grant's been with us. So locally we maintain, and international we outsource it. It's not feasible to have a physical presence for Booyco everywhere.
Yeah.
And that seems to work quite well. So not only in rail, but on the military side as well.
So what's the next step for the business?
Look, we're currently working quite closely with Transnet. We've been appointed to basically redesign and fix the cooling towers on some of their older units. We continue to look at expanding overseas. So there's a few joint ventures that we've looked at. I guess the challenge is everywhere in the world there's a drive towards local content. So it's finding the right partner so that we can provide our expertise along with their presence and supply a quality product. COVID has had a massive impact. I think the stats is that occupation of trains are down 30%. So there's been a bit of a decrease in demand for new coaches and locomotives. We've designed a standard unit for trams, because obviously a lot of major cities have trams that run. So we are currently working with a few international partners to sort of expand that international footprint. We're excited about the third-party access that's happening or could happen, depending on who you speak to. So there's opportunity there as well between our field service, mining applications, railway and military. There's a few exciting projects that we're working on to see us through the next couple of years.
So let's just talk about product innovation. You know, as technology changes.
Yes.
So diesel, electric, battery, hydrogen.
Okay.
How does this kind of impact your system?
So
where does your innovation come in?
Energy consumption. So the newer compressors, the newer components are far more energy efficient. If you compare them, for example, I was looking at a various refrigerant compressors, old versus new, a newer range, and it's 10% more efficient. So there's a drive to use same amount of cooling, less power draw. There's also refrigerant, the types of refrigerants that can be used, so more environmentally friendly. Not the older, sort of the more common ones that you find at the moment, but there's also a drive, especially in Europe, to more environmentally friendly refrigerants or zero ozone depleting refrigerants, which that's, for example, like you're talking about your CO2 systems, methane systems and such, which is, it's still very, very new, but it's where everything's going. there's a few courses we're going on at the moment just to learn about these things and actually properly implement them. So that's where product innovation is going to go towards. It's more energy efficient, more environmentally friendly. So that's pretty much what we're looking at the moment to improve our products.
All right, so you touched on open access, but surely this should be seen as quite an interesting opportunity.
We've upped our game and our standards over the last couple of years, and I'd like to think that we operate at a different level than some of our competitors. Our products are more superior, but with that there's a cost implication. It's probably more reliable. So I guess the thing that we're always faced with is your unit costs X and I can buy something for half the price. Our units have been tested. We know they're going to last. You referred to the 15Es and the 19Es. I mean, they've been around for decades and they're still working. I guess our biggest challenge with refurbing old units would be the cost element of do you want a quick and easy, cheap solution, or do you want something that's going to last? So, I mean, we're working hard on trying to get that across to the market, and also seeing what we can do that's more fit for purpose. Because it's one thing saying that I supply something that meets Bombardier or Alstom standard. It doesn't mean that a third-party provider standard is the same, but that's what that's the standards that we comply with and that we design our units to. Irrespective of whether we supply a Bombardier or someone around around the block, the same quality standards go in, the same processes go in, the same documentation goes in, because that reliability is important. There's opportunity, but there's challenges that come with that. But I'm confident that we'll get to a point where people understand what the value add is, and I think the big thing that people lose sight of is the total cost of ownership. So it's one thing to say that my unit costs twice as much, but my downtime is significantly lower. So how much money do you lose if a train doesn't operate? If you look at, Grant mentioned it in the past, that HVAC had to keep someone cold and, that was it. These days it's an occupational health and safety thing. If the HVAC doesn't work, the loco stands still. So how much money do you lose if you don't have a loco that's operational because the HVAC isn't working? So it's not just the cost of the unit, but it's the total cost of ownership. And what we've seen over the last couple of years with Transnet is that we we measure it on a monthly basis, but our total cost of ownership is a quarter of their KPI that they've set. So it runs significantly below their standards. The uptime is 90% plus. So it's so we're exceeding all our KPIs as far as Transnet's concerned. So if you compare that versus the cost of a unit, really one has to look at the total cost of ownership.